So this project here, just extended it here next to it. If I need to extend this here, which I don't need to, but it will be VG extend VG then but this one right here, if I have left out 4 gigs and I need to extend it to 9 because it was short, then this would have been the command. But since already 10, because the data volume, so the data volume group was supposed to be 10, but Prof made it I think made it 6 and left 4 out, so he went back and extended it using this command. So what my everything's set up right now, so I don't have to do that part. So everything's fine. Okay. Alright, so we'll continue. So let's see what logical volume we have so far. That's what we have so far. We did a lot already. So this is right here. So this one, the HTML should be 10, but I want to expand it or resize it to be so it's 4 right now because I did this right here. The logical volume it's supposed to be 10, so we're gonna expand it here. So I did right here. So this right here. Okay, let's create it. Alright, so this here should be 10. Alright, good deal.
Watch. Then I'm like, oh, sorry, I made a mistake. I missed something. I should have. It was supposed to be 5. So I'm supposed to use all the storage of that volume group. I repeat, I was supposed to use all the storage. How about I use all the storage? Watch this. To use all the storage, this is what I do. You run the command LV. Now in this case, I am not creating a new one. I am resizing it. So I'll say LV resize. LV resize. Then I will not put dash N because it's not a new one. I will just put the size dash L lowercase. Because I want to use all the strings in the volume. I'll put lowercase dash L. Then I will write this 100% each. That means use 100% of the volume group. Then I put now the full part of the logical volume, which is def. What? This name here, I'll put this one here. This name volume group first. The volume group. Inside the volume group, there is a logical volume that's coming from there. So put this like this. So this means this logical volume is coming from this volume group. And guess what? This is the target, right? Remember, this is the target, but this is the target. Get to the target. So this is the target. So this target, I want it to be 100% of the volume. So you put dash L to the size. Now, the only challenge here is that if you look at this command, I need to put a dash R here to tell the system that I'm resizing. I'm not creating a new one. That dash R means you are resizing. Now, if I run my command, what is happening here? 5 times. No, he's not doing it. File system check. Why? There's no file system on this box. Okay, you want me to create before I resize it? No, I want to resize while I'm installing it. It's supposed to run. Wait a minute. Is it because of that? R? Yes. Because there's no file system attached to it. Yeah, I'm always assuming that the server is already up and running, like I do it at work. Don't put the dash R, please. Take out the dash R. Take this off. Because if there's no file system attached to it, that's another reason why I was complaining. File system type. It's not seen. There's no file system. I'll show you when I have a file system on it, because that's part of what I have to do today. Now, so we resize it without, we just run this command to resize right here. Okay? This is the command, and this is the path. You know this path because yours will be different, or maybe the same like mine, not a problem. Now, if I do LVS, the size of that bar WHTML LV is now 5 gigabytes. Yeah, we have fixed that problem because we made a mistake to focus on it. Now, let's create a.
Alright, so we're going to resize this right here. We'll try to use the full size. Okay, we got a path for logical volume. So let me check on this here. So right here, it should be, let me take the bar. So on the bar. So on the bar. Okay, on the bar. In the WHTML. So okay, let's see. Alright, perfect. Good deal. And then we're going to do LVS. See, so now this right here is being resized from 4 to 5. See, 5, perfect.
That problem because we made a mistake before or something. Now let's create a logical volume for the second one, the data one. So how do you do it? Same concept. I'll do it now with just one string. Okay, so I'll do LV create -n. What is the name I want to call it? Is data LV because it's for data, right? Data is 10 gig. Then -l lowercase because I want to use 100% of the volume group. And what is the volume group? The volume group name is coming from the device. The device called what? Data. What is the volume group? Data VG. When I run this command, it's done. If I do LVS, you see here.
There we go.
That we have the data LV and the size is what 9.98. So it's using all what the volume group data or storage space. Same thing with the last one. What is the last one? The last one that we're supposed to create LV create. Okay, you know what? Let me not use that last one. It's just a repetition. I'll keep it. I'll use it for something else. You'll learn something there. Now let's leave that so I don't have to go to the DIY and do things again. Watch this. Now that I've created the logical volume, guess what? I am here. This man, I'm done with this one. So the logical volumes are created, but they have not been set up to be able to mount to this mount points. So for that to happen, I need to define a file system. So how do you define a file system? To set up a file system, the command is very simple. The command is make fs, which means make file system. Then you choose the type of file system. In my case, I will set up the file system called XFS, which you will do when you get hired. .xfs. Somebody type ext4 in the chat. I will not use ext4. It's bad news. I will tell you why. Even though it's good for some environment, but it's not the best one to use. I'll explain it. So XFS file system, right? What is the meaning of XFS file system? Let me show you something. XFS file system means that if I give this file system, assign it to a group or format a disk or create a logical volume to have this file system. If the disk size, let's say the disk size is maybe, let's say 12 gigabyte. Okay? And this disk size, this disk is running low in storage. What I can do is I can add more disk to this 12 gigabyte. I can add maybe another 5 gigabyte. I can add anything I want to add, maybe 10 gigabyte. I can add even 1000 gigabyte. I can add even 100. It doesn't matter. I can extend the disk, but I cannot shrink it. You get that? You can only do what? Take it in one direction. Extend it. Does that make sense? But you cannot compress or shrink it. It's bad news if you can shrink it. So that is why companies prefer the XFS. Do you remember what I said about on Windows about the operating system disk storage space? Remember the operating system? In Windows, what did I say about storage disk management? Don't try to shrink it, correct? You guys remember that, right? I said do not, because you know what will happen. I explained that detailedly under Windows there. So that's the same concept here. Don't shrink it. That's why they would prefer to have XFS. They would rather extend this disk instead of compressing it. Now, watch this. If you use the ext4 or ext3, okay? ext4 or the ext3, there's ext4, ext3 on the disk. It means if you have a disk size of maybe, let's say 20 gigabyte, you can choose to shrink it. You cut part of it and trash it. And then you cut it down to maybe like 16 gigabyte. So you can shrink. It's possible. Okay? So remember that. That is the thing with ext4. It's not bad, but it's not it's not the recommended one. Trust me. Red Hat will even tell you, be careful when using ext4. Alright? Now, since we have created our logical volume, let us go now and assign the type of file system to it. Okay? Watch this. Here, The command here, there are two ways to do it. So let me do the first one with the long approach. The command is make fs, which means make file system. Then I'll push -t, which means the type of file system I'm creating. And what is it again? XFS. And what is the logical volume full path? That was the var, right? So I'll say / device. What is the full path? Put the volume group first. Var ww what html vg. Then / you go now to the logical volume var ww html lv. So you must put the full path. So I'm applying this file system to this logical volume. Press enter. Oof. I made a mistake. Did I make a mistake? Yes. Yes, it's not correct. I missed the path. You guys are not talking. Come on, I thought we're friends, and I muted you guys. I put / instead of hyphen there. So now this is gonna work. There you go. It worked. So look at this. It worked now. You see, when you see this message, it means that it was created successfully. Okay, the file system was assigned, and this is your. Whenever you see this picture, a picture like this, guys, it can be an interview question. They can show you this message and say, "What does this tell you?" Just tell them that a file system of the type XFS was implemented on a disk. When you do ext4, you have like just 2 or 3 lines. You don't see all this. Let's do the next one. So the next one, I'll use a short approach, a short command. All right. Now, since we have created our logical volume, let us go now and assign the type of file system to it. Okay. Watch this. Here, there are two ways to do it. So let me do the first one with my long approach. The command is make fs, which means make file system. Then I'll push -t, which means the type of file system I'm creating. And what is it again? XFS. ext4, you have like just 2 or 3 lines. You don't see all this. Let's do the next one. So the next one, I'll use a short approach, a short command. You do make fs, that's the command. Then instead of me putting space -t for the type, right? What I'll do is make fs.xfs like this. So the short command. Instead of typing everything long, I just put .xfs. Then I put the full part of the logical volume, which is gonna be the data one. So I'll say data vg / data what lv. You see that? This will do the same thing. Watch this. You see that? Same thing. Without me wasting my time to put -t xfs. Oh, I'm showing you 2 ways. So if you see this in a code on the scripts, you know what it means. If you see this one, you know what it means. So don't get frightened by any of these 2. Okay?
Let's put this mail. Let's put data right here.
So now that I have done this, those 2 volume groups, and those 2 logical volumes, they have a file system. Now I have to mount it, but before I mount it, I need to make those directories. You must make sure those directories exist. What are those directories? The first one is the var. So I'll say make directory like this. Make directory / please pay attention. As a matter of fact, you put -d so that if the directory subdirectory is missing, you create it. Make directory var ww what html. Why am I saying that I created directory? Because part of my instruction for my manager is that we should create these 3 mount points with those sizes. So I create the first one here. So I go back here. I'll make this directory. No news is good news. Now make the second one. Make directory -b what / data. No problem. These 2 have been created. Now that these 2 have been created, if I run the command -h, you will not see anything like var html. You will not see anything like that /data. Then if I run the command data, good news. Now make the second one. Make directory -b what / data.
Okay, great. Speed. This one.
No problem. These 2 have been created. Now that these 2 have been created, if I run the command -h, you will not see anything like var html. You will not see anything like that /data because they are not mounted. For me to mount it, there are 2 ways to mount it. I can mount it like that. So these 2 have been created. If I run the command -h, You will not see anything like var HTML. You will not see anything like that slash data because they are not mounted. For me to mount it, there are two ways to mount it. I can mount it temporarily, like this. To mount it temporarily, I'll do both. I'll do one temporarily, the other one persistent. To make it to be temporal mounts, just run the command mount, like we did when we were doing repository. You guys saw it, right? You saw me do that, right? To mount it, just type the command mount. When you do mount, put the source, then the destination. Meaning you put the file system first, then the destination. So I'll put def. Let me use the var first. Let me do the var www html what pg / def. Oh, sorry, my bad. Var www html LV. Yeah, I get confused. I'm looking at you guys distracted, so I want everyone to pay attention. This is the source where we had the logical volume. Then where is the destination? The destination is that direction that I created here. All of this / var / ww / html. You could give this name anything, but I like to give the name something that will match it so that I know that it's coming from there. So when I run this, it's mounted. How do you know? To validate it, run zf-h. Do you see now that we have a var html here? You see it? This mount is the
Yes. Okay.
size HTML here. How do you know? To validate it, run zf-h. Do you see now that we have a var HTML here? Do you see it? This mount, you see the size is 5 gig. This is temporal. This is a temporal mount. So I have mounted the first one temporarily. Let me mount the second one permanent. How do you make it persistent? Temporally. Let me mount. This is temporal. This is a temporal mount. So this mount, we have a var HTML here. You see it? This mount, you see the size is 5 gig. This is temporal. This is a temporal mount. So I have mounted the first one temporarily. Let me mount the second one permanent. Okay, make it persistent. How do you make it persistent? You vim into the Etsy FS tab. You go into Etsy / FS tab. FS tab stands for File System Tables. Okay? You know the Etsy is where we keep configuration files. FS tab means the File System what? Tables. So vim into that.
This is to make it persistent, right?
Into that, man. Go all the way to the bottom. You already see some good things in there, but this is what you do. Go all the way to the bottom, right? Press I for insert. You know what to do, right? Let me go to the M there, press enter. Put a pound sign to differentiate what you have created and what the system created. Now, here, the first thing you put here, the first thing you put is that file system path. So you put /dev / data / data vg / data lv. So I'm mounting the second one first here. I'm mounting here to be persistent so that you see the difference between doing it on command line and coming to a file and writing it. You see one disappear when I reboot the system. Then what is the mount point? The mount point, let me just put that here. The mount point is /data. That is the directory. That's the mount point. Then tab. When you do that, the next thing is the file system, which is what XFS. Then you push tab. Then you write what? You put defaults. This you always have to put in there. Then you put tab again. Then you put 0 space 0. This one must always be there at the back end as it is here. I'll talk about it again. But remember this one here. This is the file system. You want to specify it. Now, if I press escape and I save this and I quit, guess what? I will run the command. If I do gf dash.
Okay. I'm missing something. G. E tab data XFS defaults 0 0.
if I press escape and I save this and I quit, guess what? I will run the command. If I do gf-h, even though I put it there, it's not data is not showing here yet. For me to make sure that the one that I put in the file system is mounted, run the command mount-a. That means mount all of them. Mount everything. So when I run this command, this message always comes up on Red Hat 8 and 9. Don't worry. It just means you have to reload the daemon, but you don't really have to reload it for it to show. But I will just reload the daemon because the same is asking for it. When I do so, run gf now-h. Do you now see that there is data down here?
Yep. Okay. Yeah. Switch. Okay. Sure. Let's see
here. You see slash data as we mounted, and you see the size system key. Now, remember, this bar WHTML, I did that on the command line, correct? It's not persistent. Let me remove this box. Let me remove the box, and then you see what happens.
Okay. So this one we didn't come online. This wasn't persistent. It was temporary, right? And then data one, we did it right here. So it's data. Let's look at the difference. So the permanent persistent one doesn't have the dash like this one. So we're gonna reload and see how it looks like. Let's reboot it. Good. Alright, get back in. What you see?
Give it a few seconds. Oh, nice. Oh, I hope you guys bought Dutch. Like 2 days ago or yesterday. Anyway, the box is back on. Let me reboot. Let me log back in as the root user ID so I don't have to waste time switching. Oh, my password is wrong. Now I'm back in the box. Please pay attention. Now that I'm back in the box, if I do gf-h, you notice that data is still there. But what happened to the bar WHTML? Do you see it anywhere? It's gone.
Yeah, the other one that has it dash is not there.
Guess what? I will run the command. If I do gf-h, even though I put it there, it's not data is not showing here yet. For me to make sure that the one that I put in the file system is mounted, run the command mount-a. That means mount all of them. Mount everything. So when I run this command, this message always comes up on Red Hat 8 and 9. Don't worry. It just means you have to reload the daemon, but you don't really have to reload it for it to show. But I will just reload the daemon because the system is asking for it. When I do so, run gf now-h. You now see that, but I will just and 9. Not all of them. Mount everything. So when I run this command,
It does not show here yet, so we need to mount it all. I'm doing mount 8. That's 8. Start rebooting.
For me to make sure that the one that I put in the file system is mounted, run the command mount-a. That means mount all of them. Mount everything. So when I run this command, this message always comes up with Red Hat 8 and 9. Don't worry. It just means you have to reload the daemon, but you don't really have to reload it for it to show. When I will just reload the daemon because
I think it's alright.
When I do so, run df now-h. Do you now see that there is data down here? You see /data?
Yeah, we just already
mounted, and you see the size is 10 GB. Now, remember, it's gone. So that one was temporal mount. This one, the data is inside the file is called persistent mounting. So that what happens to the var. I'm back in the box. If I do df-h, you notice that data is still there. But what happens to the var HTML? Do you see it anywhere? It's gone. So that one was temporal mount. This one, the data is inside the file is called persistent mounting. Okay. So for me to make the var HTML to be persistent, vim into etc fs tab. That is an interview question. Eh? How do you make something persistent? How do you make a service to be running all the time even when you remove the box? You make it to be persistent by doing what? You do systemctl enable the application or the service, correct? How do you also you know? You guys have done one, so you should know that one. So now let me put that one for the var. So there's the dev device var www html vg / var www html lv. Then that / you know what, I'm lazy. Oh, let me just do it right. Let me just type it. Var www html. That's the mount point. Then I put what the file system is xfs tab. Then guess what? I put default tab. What again? 0 space 0. Press escape. Save that, and then you.
Logical login. That's the financial though. They're going reboot.
Wait, systemctl daemon reload.
Reload. Then reboot.
Then when that is done, I do df-h. You see it? This is the var HTML.
There we go. Right, so it's back. It's back right here. Right here.
And this is the data now. Even if I remove the box, they will still be there.
And this is the data. Wonderful.
How do you know that you can use them? How do you validate? So cd into one of them and then do some work. For example, here, I cd into this /data. I can create some. I can do something there. Let me do what? Let me copy. No, I'll copy everything from the temp directory. I'll copy everything from /temp directory. I'll copy it here. So let me do copy / temp. Copy it here. Omitting directory. Okay, you know what? I'll copy it. Yeah, we'll copy it. Copy it recursively. I'm supposed to. Yes, override everything. Yes.
So CP. Wait, this right here. Is in.
Okay, done. Oh, not yet. Okay, there you go, it's done. Now, if I do GF-H, you see that data, was it data? Yes, data has 2% usage and all that, and this is data directory. If I can copy something inside here, if I can copy
2%.
Data has 2% usage and all that, and this is data directory. If I can.
What is that? Data is right here. 2% usage. Okay.
Can copy something inside here. If I can copy things and put it inside this directory, it means it's usable. Now, let me delete. You know what? Let me not delete it. I will show you something. Leave it in there. Please pay attention.
Let's go back in here. My copy didn't work.
You see that data was in data here. Data has 2% usage and all that, and this is data directory. If I can copy something inside here, if I can.
So my copying didn't work earlier. I was trying to copy it. Let's see if we can fix that. The copying thing. Let's go back.
Let me look at this. This is the bar HTML, and this is data now. Then when that is done, I do GF-H. I do a system daemon reload. Then you run the command mouse-A.
I don't pass that.
Then I do what?
So there's nothing there, but let's copy. Let's copy. I think this already, right? So copied from the temp. Go inside there. Copy from temp. Okay, copy it from the temp into the data. Okay. And anything's out here. I don't think there's anything out here. Let's see. There's nothing showing us out here.
Oh, not yet. Okay, there you go, it's done. Now, if I do GF-H, you see that data was in data here. Data has 2% usage and all that, and this is data directory. If I can copy something inside here, if I can copy things and put it inside this directory, it means it's usable. Now, let me delete. You know what? Let me not delete it. I'll show you something. Leave it in there. Please pay attention.
So I couldn't. So let's say I couldn't copy it inside here. So that means mine's not usable right now. So, so what's the reason for that?
Okay, there you go. It's done. Now, if I do GF-H, you see that data was in data here. Data has 2% usage and all that, and this is data directory. If I can copy something inside here, if I can copy things and put it inside this directory, it means it's usable. Now, let me delete.
So I was able to copy it inside of the directory, so I can see nothing in here. Let's see. So nothing was in here, but person showed. So let's see.
You do GF-H, it will show you these things, right? But if you want to see the file system of every mount point, because they can actually interview, how do you see the file system of every mount point that you created? Do a GF-H normally, then add the letter T to it. Do you see that it shows you the file systems here? It says now type. You see the file systems here? You see it? When I run the GF-H, it doesn't have the type. When I add dash T to the uppercase, it shows me what the file system is here. So please, I will recommend you remember this. You need to know the file systems of every mount point. Yeah. With this, please look up. We have created those things, right? Created those file systems, and we have those stuff. Now, I told you where am I located? PWD. I'm inside /data. Now, pay attention to database troubleshooting when it comes to latency. My manager will ask. I don't even want them to ask me if I go to the interview, man. I'll talk about this. So my manager will ask me this sometimes though. He will say, how long does it take for a file to be read inside the mount point that you created? So I'll go into the mount point, CD into that mount point, look at the file, look at this. I'll pick a directory, for example. Let's say I pick a directory. I want to see how long it will take me to list any content in here. So see what I'll do. I'll run the command time, okay? Time ls in here. Watch this. This is the time it will take me. Please pay attention. This is the time it will take me to list the content on this mount point. 0.003 seconds. So in real life, for a user, it will take no time at all, 0 seconds. For the system to read the file, it will take it 0.04 seconds. You get it? Listen, this command, right? Time ls. This is a test of performance. When you work on database servers, because database has files and data, right? That the application server will be reading over a network. So we use the time command, time ls, to see how quick it will take for that web application to read the data on the back end on database. Please.